Thanks, Dmitry. Yeah, hi everyone. And today I want to talk about performance testing in Fintech landscape. So let's talk about me. So my name is Nikolai, right? So I'm working dev experts and position performance QA engineer, right? I worked for large banks and have extensive experience in performance testing, right? And also I'm trying to learn Portuguese. Some words, for example, bom dia, boa tarde, and other one like. Okay, so let's start my presentation. So today we talk about what is performance testing in Fintech, right? So what we test and how we test it, and also we talk about our testing process and how we analyze our results. So let's start. How do you think what performance testing is? It's a question. Like.
Well, to ensure that system properly works under the law.
Yeah, correct. So right, it's a version what is performance testing by ChatGPT, right? So, okay. So performance testing, it's a type of non-functional testing to ensure how system works under a high workload. So we measure such parameters as speed, system scalability, system stability, and system reliability. To measure all those parameters, we use different types of tests, such as load test, stability test, spike test, WOLMI, and other types of tests. So, but performance testing in Fintech have a number of different requirements. They should be taken into account. That is a large high load and transaction speed. We have a huge amount of data used for exchange during the day. We have a special government regulations because we work in fintech industry. We have stronger SLA requirements because exchange should be work during the trading day. And we need to have a good stability and elasticity because if something goes wrong, we have a lot of problems. Okay, here we have our system architecture. You've seen it before, right? So we have different types of channels. So we have desktop GUI, admin GUI. We have web and we have mobile devices. Also we have server components with different types of applications and system bus between them. And we have external services. So in our performance team, we test server components and we test external services. And what is our system requirements? We have custom protocols, right? We need to simulate real-world scenarios with different types of orders and different types of their execution. We have a large number of different tests because we have a lot of components and we need to test them all. And we have a lot of different types of metrics and we need to analyze them, right? So let's talk about our testing approach. So we have different types of solutions. We have a trading scenarios, right? It's the most complex scenarios what we have. We have non-trading scenarios. They're advanced but not so complex. And we have other types of scenarios. It's various short-term tasks. For each type of these scenarios, we have different solutions. So for trading scenarios, we have custom tools. We have UTT, it's Unified Testing Tool, and Perf-utils, it's performance utils. And for non-trading and other scenarios, we use standard tools such as Gatling and JMeter, right? So let's talk about each tool, right? So custom tools called UTT. So what is this? It's a client tool written on Java. Have like all execution logic inside. Can emulate complex logic scenarios with different types of orders and order execution. and we can create scenarios with configuration file. So for example, if I want to create a test, so I need to put inside configuration file different types of orders and how we will execute them. And I will have a completed test. But it's not one, like a fully, it's not one full part of our test, because we need to also schedule a test, prepare a test environment before we starting them. Also, we need to create a new, for example, if we want to run our test on AWS, we need to prepare and start instances before we run in test. And to solve this problem, we create our solution performance utils. It's automation framework for run performance tests. It has option to add new tests from other sources. Has configuration files for different tests, and can automatically create reports after each test. So for standard tools, we use Gatling, and Gatling is good for tests with complex logic and have all code tests. And we use JMeter. It's good for simple tests, have low code tests, and have a lot of different plugins and extensions. So we use both of them. Both of them depends what we need. So each tool have their pros and cons, but I prefer Gatling because I can create tests using only code. And now Gatling have a Java implementation. So if you want to write your performance test, you can use only Java. That's all. Okay. So when we talk about our testing process, we have what we do in our team, right? So we have release regression testing. We analyze test results and optimize application performance. So what we do in for release regression testing, we run tests for each new release, keep platform up to date, so we maintain it, update some data, fix if we have any problem, and create a new test for new features. For optimize application performance, we find bottlenecks in our applications. We perform retest after bugs fixing, and articulate problems with stakeholders and developers. And for analyze results, we create report after each test. We analyze service and host metrics, and compare tests between different versions. So let's talk about some our case studies. So we have a problem, right? So we have a lot of different metrics and difficult to analyze because, for example, in our platform we have 100 hosts, and we need to collect from each of hosts service metrics like CPU, memory, disk I/O, and network, and like it's a lot. Also we have a problem delayed reaction to key metric changes. So for example, if we miss something, the bug can go to production, right? And how to know at what point in time the metric problem began. So for example, if we have some problem, the first question is which version have this bug, right? To solve these problems, we find a solution. We add baseline for each metric. So what I mean, for example, if we have a current version of our report, we add to report two previous versions and can compare to previous versions. Here we have only previous version, but in our report we use two previous versions. And we can compare for each metric, for example, for CPU or for memory, how it changes. And if we see the metric is changed, we can analyze. So we have a problem and see why it's happened, right? So it's a very good solution. And we have a problem. So performance environment have to replicate production environment. So we have a lot of different hosts. For example, if we talk about basic QA environment, it's used one instance for each type of application, for example, one database, like one host for application, one web interface, right? But when we have performance environment, we have a lot of different hosts. A lot of sources, it's mean tons of data, right? And reports should be include different metrics and different representation of these metrics. Also, we need to create a lot of different wrappers for different tests, because we have core tests, we have mobile gateway test, we have service gateway test, and other types of tests. And we spend a lot of time to create each of these tests, because we need to create them manually and collect a lot of metrics. So a solution to this problem was a custom report automation. So for example, for each type of test, we create a report automatically and can set up it for different like types of tests and add some metrics inside. So here our report example. So we have our report have a different like a result, like not different slides with different types of metrics. We had a text description with all metadata related to test. We have different types of charts and different types of metrics. For example, here is metric comparison, and the second slide is chart comparison. So how you can see here, right? So we have blue, orange, and green versions, right? And if you see how you can see on chart, we have no difference between blue and orange versions, but we can see, so in, for example, the latest current green versions, we have some change. So we see, so something is different, and we need to analyze, so it's normal or not, right? So for example, we can find so here it's normal, right? But sometimes we have a lot of like a problem, and we need to fix it and retest it. Okay, so summary. Today, so performance testing is very important, right? So challenges, we have a lot of different challenges in complex systems. So if you have different scenarios, you need to create a different, use different tools, and maybe create your custom tools. For example, for problem detection, the best thing is use baselines for each metric. And if you not yet have a automation for reports, you should develop automation for your reports, right? So thank you all, and feel free to ask your questions.